Before you start to watch this video, I want you to take a moment and attempt the opening exercise. After you've attempted this opening exercise, we should know that a rigid motion preserves length and angle measure. So you should have some explanation of that written on your paper. Additionally, we want to be specific and explain exactly what type of rigid motion occurred here. So to map one triangle onto the other, it would need a reflection, and it would reflect over the line BD. And we want to even be a little bit more specific by mentioning where the other point is being mapped to. And because there's no indication of which triangle is mapping onto the other, we can just say mapping A onto C. So if you wrote something along those lines and added in that rigid motions preserve length and angle measure, you would be perfect for that opening exercise. These were the first situations we've dealt with proofs. So proofs indicate that a shape can be mapped onto another shape. We're really going to look at triangles. Now we want to make sure that all the sides and all the angles always correspond to one another and could be potentially mapped onto one another. Because that would become really tedious to have to prove 6 sides, 6 angles every time, we're going to use some triangle congruence theorems that kind of help us eliminate doing every single side and every angle every time we want to justify that they're congruent. The first method we're going to look at is the side angle side method. That means that if I can get two sides, like AB, they correspond to one another, and AC and A prime, C prime, if I can get two sides and the angle in between, that means the entire triangle has to be congruent. They would have to map onto one another, because think in this case, like with our translation, all the sides and angles would lie on each other. So we're going to attempt to do a side angle side proof. So we've dealt with little baby proofs and indications before. So I know I want to prove by side angle side. So I'm going to write that out. And I'm going to look at our picture here. First thing I know is the given. So to keep all of our ideas organized, I'm going to suggest that we still write out our table, our statement and reason table that we've been doing. So statement and reason. Okay, so that being said, remember your first step is always to write down exactly what the given says. So AB is congruent to CB, and that's just an end symbol, BD bisects the angle ABC. Our reason is just because we know that. It's our given, we were told it, there's no guessing, it's exactly what we know. So because I know that, I'm going to look at my picture here. I can indicate that AB and BC are equal, or congruent rather. So I'm going to give a little check. We have one pair of sides that are corresponding, so we have the sides. If I look to the next part of our given, BD bisects the angle. Remember, a bisector cuts an angle in half. That means the two parts of this angle are going to be congruent. So we would say angle ABD is congruent to angle CBD. Okay, so we can just justify exactly what we know about an angle bisector. An angle bisector creates two congruent angles. You could use symbols, you could write it out however you prefer, but now we have our angle, so we have a next step done. I'm out of information from the given. I have nothing else to look at, but my goal, remember, to prove that triangle ABD is congruent to CBD. So something you should notice as I highlighted my triangles is that we overlapped at this one particular location. In our previous lesson, anytime you want to prove that something's congruent to itself, this is something being used in both triangles, we can say that. We can say that BD is congruent to itself because it's the same exact side. Nothing changed about that side. If we use that, that's known as our reflexive property. So a segment or an angle that's congruent to itself is the reflexive property. If you just wrote reflexive, that'd be fine. But notice that was my third check. BD is in both triangles, so it counts. But we always want to end with what we're trying to prove. So in this case, we're trying to prove that the triangles are congruent. So we're going to say that triangle ABD is congruent to triangle CBD. And the reason why we know that is by side, angle, side. So we can just write it as SAS. So that's our first method of proving triangles are congruent. Our second is very similar, only this time it's angle, side, angle. So we're talking two angles that correspond and two pairs, but the sides in between them. So we're going to just go right into it and try to do it again for exercise 2. So we start always with a statement and reason. I'm just labeling it as S and R. That would be full credit. Remember, first step is always Q is the midpoint. Of SN. And we have angle 1's congruent to angle 2. So we always start with that because that is our given. This is information we know for sure. Now, one piece I can take out of the given that's really helpful for us is this right here, angle 1 congruent to angle 2. I don't have to say anything further about that. I already know that out of my angle, side, angle that we're trying to prove, I've got one corresponding pair of angles. Now, when I look further here, back to the given, I know that Q is the midpoint. Once you see one of your vocab terms, we can use that to help us. We should know at this point a midpoint cuts a segment, in this case SN, into two congruent segments. So we can say SQ is congruent to NQ. Our reason, just exactly what we know here, is that midpoints create two congruent segments. And I can abbreviate that to seg. It's fine as long as I get the idea of what I'm trying to do. But I'll give myself a second check because the segments now are checked off. If I look carefully, I know that I'm out of information from my given. There's nothing else that I can get from what I've been told. So in this case, I look to the picture to see if there's something that I know is true. Every situation, these two angles are congruent. And I can write out the angles SQR and NQM. But since we're using the 1 and 2, we can label this 3 and 4. As long as your triangle's labeled, we can say angle 3 is congruent to angle 4. The reason being is these are vertical angles. And vertical angles are always congruent. They're formed by intersecting lines. So it's not just this diagram. Anytime you have intersecting lines, they're congruent. So we're safe to just say that without worrying about justifying. And that was my third check. So I have angle, side, angle, which means I can say that triangle SQR is congruent to triangle NQM by angle, side, angle. So far we have 2 out of the couple different ways of triangle congruence. We're going to wrap it up with one more way today. So on the back side of your guided notes, the last method is side, 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 which we've actually done before through construction. We've taken a segment and copied it to a new location. We've followed that process for all of the corresponding sides. So we know side, side, side would have to preserve length because it's the same exact sides. Angle measure would have to stay intact as well. So we're going to try to look at our proof with side, side, side. I'm going to set us up with a table to organize our ideas. Oops, back to the page we were on. Now remember, first step is always the given. So I don't have to write the whole in the following. I want the big geometry ideas like WY is the median of XZ. And we also know that WX is congruent to WZ. So that's my given information. I know that for sure. There's not a doubt in my mind that I'm positive of that because I'm being told it. So I'm even going to mark that WX is congruent to WZ. Okay, it's what we know. So that means out of that side that we're tracking, we already have one check. If you remember from the beginning of this page, if I'm looking at the two triangles that I'm trying to prove congruent, I already have something that overlaps in the picture. So if I even want to take a break from the given, I can identify that I have the reflexive property. So I have YW or WY, either order, is congruent to itself. And anytime we use something that's congruent to itself without changing its location, it's the reflexive property. So it counts for both triangles because it's a part of both. So 2 counts. We have 2 checks already. We need one more. That's when we go to try to figure out if we have a definition nearby. And we do. Median is a newer set of our vocab terms, but remember, if that's the median, it connects to the midpoint. So we could say Y is the midpoint or is midpoint. Like, we don't have to worry about writing out grammatically correct. I care that you hate the major ideas. So Y is the midpoint of XZ. Our reason is because a median connects to opposite sides midpoint. And from the front as well, we should know that a midpoint will cut our sides in half here. So we can say XY is congruent to ZY as midpoints create 2 congruent segments. And once we have that third check, once we have everything intact, we know to wrap it up. So we always end with what we're trying to prove, that the triangle WYX is congruent to triangle WYZ by side, side, side. Now, these pictures are looking similar. You can have the same things, and you can prove things multiple ways. It's never going to be a one-size-fits-all for proofs. You might prove differently than I did. And once you know your vocab and you understand the clues that you can use, there's plenty of different ways to go about these. In fact, when we look at exercises 4 and 5 here, they don't tend to give you the congruence that we want to use. So when we attempt to prove, we're kind of on our own to kind of figure out that organization. We always know where to start, though. We always start by writing the given in. But let's just look at the information we have here. We know that BD is the perpendicular bisector. That information's huge. Perpendicular forms right angles, and it also bisects. With that being said, I also can probably find the reflexive property. That's going to be a side angle side proof. If I look down to the bottom and skip ahead, if I look at my statement and my reason, if I set that up again, this time the big idea is that they bisect the angles. So I'd have these congruent and these. With the reflexive, I'd say angle, side angle.